5 of the biggest branches missing from the animal kingdom. Number 5. Archaeothids. Archaeothids were an ft long for this world, but they did great things in their brief time. The first archaeothids appeared in the fossil record 542 million years ago, in the Precambrian period. Like modern sea sponges, which they were probably related to, archaeothids formed hard, porous calcareous masses, though they were rarely more than 15 centimeters high. They formed cup-shaped and tubular structures on the seabed. Archaeothids probably fed even more simply than modern-day sponges, by passively straining food particles from water passing through their porous structures. They also lived in symbiosis with blue-green algae, which they would have fed upon as well. This group successfully branched out into hundreds of different species, becoming a stable part of shallow marine seafloor communities in tropical regions around the world. They formed large masses on top of their own accumulated remains, which helped form the first reefs in many areas. Thus, they created important marine habitats across the lower Cambrian world that would have helped to nudge more familiar animals along their own evolutionary paths. Within a mere 20 to 25 million years, by the Middle Cambrian, they had disappeared entirely. No one knows why, but it was likely due to competition with some new kind of browsing predator or better adapted filter-feeding sponges or corals. Number 4. Helicocodes. The helicocodes are known only from the Lower Cambrian period, 525 million years ago. They were some of the first echinoderms, the group that includes modern-day starfishes and sea cucumbers. Helicocodes resembled tiny, 3 to 7 centimeter long armored footballs that could stretch and contract their bodies. They had bizarre feeding grooves which spiraled along the lengths of their bodies and were some of the first animals with skeletons. They are believed to have lived upright in vertical mud burrows in the microbial mats that grew in the shallow, silty bays around Laurentia, the primeval continent that once spanned from British Columbia to California. They fed on plankton and organic detritus from the water above. In geological terms, the helicocodes went extinct rather quickly, lasting only 15 million years. They didn't survive past the Lower Cambrian. It's possible that more mobile descendants succeeded them, which perhaps evolved into the starfishes, sea urchins, brittle stars, and sea cucumbers of today. Our contemporary understanding is that helicocodes were simply too specialized to life in soft, static mudfields and were unable to survive when burrowing animals evolved and proliferated, rendering their habitat much less dependable and severely altering its water currents. Number 3. Halluxids. A particularly confusing array of soft but scale-armored animals arose in the early Cambrian period, and they continue to perplex paleontologists to this day. This odd family of critters is tentatively believed to be an ancestral form of mollusk, perhaps an ancestor of today's clams, squids, and snails. The Halluxids comprise the slug-like genus Wiwaxia and an associated worm-like genus called Archaea as well as a handful of other isolated oddities. There is little concrete evidence to prove that these animals were related at all, as their characteristic armor plating could have evolved independently. An example of Wiwaxia is Wiwaxia crigata, which was 5.5 centimeters long and had 2 rows of long, blade-like defensive spines running down its back. The Halluxids didn't survive past the Middle Cambrian. Some scientists attribute their extinction to the decline of the bacterial seafloor mats upon which they fed, due to the proliferation of burrowing animals, which altered the stability of the Cambrian mudbeds forever. Number 2. Denacurids. The denacurids, or terror shrimp, swam through the Cambrian seas about 515 million years ago. They were sight-based predators with some of the best eyes of any arthropods ever, and they lived in oceans around the world. Denacurids were veritable titans in the Cambrian seas. The 1-meter-long genus Anomalocores had a bizarre whiskered mouth with 2 long feeding appendages. How exactly they fed continues to baffle scientists. It's possible that they hunted tiny trilobite species, but it seems more likely that they drifted through the waters like a modern-day whale shark, filter feeding on plankton or browsing on soft-bodied worms. Some groups indeed moved away from predatory hunting to become specialized filter feeders, harvesting plankton like a baleen whale and growing to immense sizes on this abundant diet. The largest found so far is Archaea bentley, which reached 2.1 meters in length, making it one of the largest arthropods ever. The 10-centimeter-long cinderhand Bartelsii, the last known Denature, disappeared 390 million years ago during the early Devonian. Perhaps the Denacuridids' cooled neft handle increased competition from more modern predatory animals like squid and armored fishes, which became increasingly big players after the end of the Cambrian period. Number 1. Blastozoans. The blastozoans represent a vast branch of primeval echinoderms that grew from elongated stalks, somewhat like modern-day sea lilies. They were one of the first forms of echinoderm, arising in the early Cambrian. They were extremely successful, being much more common than helicoplacoids and other early echinoderms. One of the most common early Cambrian forms was the flower-like genus Goggia, which grew on Archaea reefs and trilobite shells around Gondwana, an ancient supercontinent. Goggia was the tallest echinoderm of its day at 10 centimeters. The genus was probably restricted in size by the loose, shifting, soupy mud of its time. Blastozoans underwent a radical diversification over the Ordovician period, branching out into many kinds with highly diverse forms that became some of the most successful and characteristic animals of their age. Several kinds of blastozoan even made it through a horrendous global glaciation, though only a single group would go on to survive until the late Devonian mass extinction that was unleashed on Earth 70 million years later. These last holdouts bore the adorably retro sci-fi name of blastoids, and they tenaciously clung to life until yet another epic catastrophe in the Permian period nailed them once and for all. They died out 262 million years ago during the Capetanian extinction,